organized in the framework of Task64, subtask E guideline to market. There's some more information on that later. As a first remark, this webinar will be recorded. So in case you don't agree to the recording, please leave the webinar. So Wolfgang, you may start the recording now. Welcome again, everybody, to this workshop. And before starting, some important information. Your microphone and camera are disabled by default, but you can ask questions on the contributions to this webinar in the end, in the Q&A session. And you can do that by either raising your hand using the respective function of Microsoft Teams, and then your microphone will be enabled by the moderators, or you write your question in the chat. And please state with your questions your name and affiliation and to which of the three contributions the question is addressed. So the webinar is organized in the framework of the IEA joint task Solar Heating and Cooling Task64 and Solar Paces Task 4, Solar Process Heat. Now, what is this task about? Just for your information, the International Energy Agency is providing a framework for international expert groups to work on different topics in the framework of so-called technology collaboration programs, TCPs. In these TCPs, typically technical topics are defined in tasks or so-called annexes, where technical topics are discussed and addressed by groups of international experts. Here we have the TCP Solar Heating and Cooling, SHC, and the TCP Solar Power and Chemical Energy Systems, abbreviated Solar Paces. And each TCP has about 20 to 25 contributing member countries and invites experts from science and industry to contribute to the discussion. A lot of information is publicly available online on the IEA SHC or Solar Paces websites and the respective task websites, both on the active tasks, but also on former tasks where a lot of very important work and international publications have been provided. Now, in this joint task on solar process heat, we again divided the work into 5 subtopics in subtasks A, B, C, D, and E. And you can read the topics. They are more or less self-explaining. This workshop is part of the work in subtask E, guideline to market, where we intend to support the market upscale and to contribute to mitigating non-technical market barriers. For more information, you can see the website, and also one advertising remark, the final task expert meeting of this task will be held very soon, 19th and 20th of October in Seville, Spain. Now on the workshop today, we have 3 contributions followed by a question and answers and discussion session. The first contribution will be given by Christoph Brunner of IEA Intake on ship technologies, best practice examples. The second contribution will be given by Winfried Braumann, founder and CEO of RENAC, on financing models for ship projects. And the third contribution is given by Slawomir Hus, partner of Solars Capital of Switzerland, on experience on financing small-scale decarbonization projects on cash flow basis. With this short overview on the agenda, I pass the word on to Christoph Brunner, and I'm very curious to learn more about financing of ship projects. Christoph, the floor is yours.
Thank you very much, Peter, and I'll share my screen. So you can see my screen?
Yes, but not in the presenter mode yet.
Just a moment. No?
Yes.
Okay, good, perfect. Yeah, thank you very much for this nice introduction, Peter. And yeah, good morning, everybody. I was asking, thank you for the invitation. I was asked to give a very brief introduction to this topic, less from the financial point of view than more from a technological point of view. And yeah, so I will start immediately. This, let's say, the importance of heat in industrial energy systems. This is maybe not for everybody aware that about 74% of the total energy demand in the industry is related to heat, and only 26% to electricity. Of course, there will be in the future an ongoing shift more to electricity due to the fact that more and more heat pumps will be installed, the electrification of processes and new technologies will go on in the future. But nevertheless, there will be also, if this electrification is going on, still a huge amount of heat necessary to provide to the industry and to provide for the production process. As you can see here in this graph, most of this heat is allocated to fossil fuels, coal, natural gas, oil, for example, so only 9% is allocated to renewables. And another important point, what I want to highlight, is that there are different temperature levels needed for covering this 74% of heat. We have about 30% below 150 degrees, 22% in this range of 150 to 400 degrees, and approximately 48% above 400 degrees. This is related to the industry sectors. Different processes needs different temperatures. And maybe you ask now, why is it so important to know or have this knowledge about temperatures? On the one hand, and I will come up to this later, for energy efficiency, to know how can I use waste heat, excess heat for the process to supply different processes. And on the other hand, and this is the topic for today, for solar thermal technologies, because solar thermal technologies are very close, so the temperature is very close related to the efficiency of the collectors itself. Yeah, what is now a future system, energy system for industrial? How should this look like? It will not be like in the past that only one fossil energy carrier is supplying the energy to the industry, like oil or like natural gas. There will be a hybrid system, again linked to the different necessities and of the production processes, but also linked to the availability of the renewable energy sources. And this is mainly related to renewable energy sources like biomass, biogas, green gases like hydrogen, green hydrogen. So what are the challenge for renewable energy supply in industry for the future? On the one hand, this hybrid system to optimize this interlinkage between different renewable energy sources like solar thermal, hydrogen, biomass, heat pumps, etc. Then this energy supply under an exegetic considerations. What does this mean? To have a good knowledge on the temperature levels where the energy is needed, and to use this technology, these renewable energy technologies, which fits best to this temperature range. Again, efficiency is here a keyword. And then matching these volatile renewable energy sources, solar sources, with the different load profiles of industrial processes. So we have a load profile of the processes, batch processes. Not all processes are continuous. Some processes are running in nighttime. And on the other hand, we have volatile solar resources, volatile renewable energy sources. And to match this best, this will be a big challenge in the future. And then, of course, these energy management systems, including the integration of waste heat recovery within a company itself. This graph should show you an overview how such integration of renewable energy and specifically solar thermal could look like, or will look like very schematically into industrial systems. So we have on the one hand the technology, this is supply technology, then in most of the cases a storage technology, and then we have the integration point and the processes itself, and maybe also this link with other technologies, supply technologies. So on the one hand, solar thermal systems, then the storage is crucial in order to fulfill this mismatch, or to overcome this mismatch between volatile solar sources and, on the other hand, the load profile. And then the conventional heat supply in combination with the processes and to optimize the demand of the industrial processes. This graph gives you an idea which kind of solar technology, solar collector, fits to which industrial branch, which industrial sector. We have on the one hand the different temperature ranges from 50 degrees up to 400 degrees on the upper level, and on the lower level you see different technologies. So it's coming from flat plate technologies, which are suitable best for low temperature purposes. Then we have evocated tube or CBC collectors, which are in this range from lower temperature up to 120 degrees, 130, 140 degrees. And then we are coming to the solar technologies of concentrating systems. And here we have parabolic trough collectors or Fresnel collectors, which are in this range up to 200 degrees, 250 degrees, 300 degrees. And then, so these are the small concentrating systems. And then on the upper end, we have this large large parabolic trough or the large concentrating systems. And in these blue areas, you see the different industry sectors and branches. Also below 100 degrees, we have several branches. You find in different industry sectors, different processes which are running between 50 degrees up to 100, 120 degrees. The chemical industry needs higher temperature from 80 up to 400 degrees. A branch in the which the energy demand at the lower level is in the food and beverage industry and paper industry. And then we have also in the field of machineries, equipment, textile, also a lot of processes in a rather lower temperature level, which fits, of course, based on the efficiency for solar process heat very well. So as you can see here, or as you can see, there's a big potential to integrate this technology in different industry sectors, to show that there's not only the potential, but also realized existing plans. We created a database, an online database. The link to this database you can find here on this slide. It's www.ship-plans.info, as a solar heat for industrial processes. SHIP stands for this. And here several systems recorded worldwide. You have here a map with the different locations of realized systems. And the interesting part is that you can select these different best practice examples by country, by different applications, also different processes, different industry sectors, by the solar company, by the collector technology. Is it a concentrating system or is it a non-concentrating system? The year of installation, etc., etc. So it's really a good showcase to see, okay, in which areas we can find best practice examples. I took out of the solar heat worldwide statistics one graph from 2023, where you can see which industry sector has, let's say, the highest number of installed ship plants and the highest thermal power of these total plants. And as you can see here in this graph, the food industry has the highest number, 148 recorded plants, and the highest capacity thermal power can be found in the mining industry. Yeah, this depends, of course, on the food industry, beverage industry. There may be some smaller installations. In the mining industry, we have a few, 22 very large installations. But as you can see here in this graph too, there are worldwide nearly in a high number of different industry sectors already best practice examples.
Christoph, you are muted, sorry.
So now you can hear me? Yeah.
Yeah.
Yeah, sorry, it seems I clicked wrong. Yeah, so you see here different examples of installations out of our database. On the left upper corner, you see this an example of a brewery where we have quite good links here in Austria, but also examples from Switzerland with concentrating systems for the dairy industry, from Nicaragua for drying of coffee beans, for example, down to textile industry in China. So really huge, huge collector fields, very good examples from different sectors. And all this information you can find in this database. Yeah. There was also from the company Solrico an outlook of the different ship data planes for the future. So what can be expected? How many ship installations should be fulfilled in the next years? And this graph shows you that there's a doubling of capacity from 2016 to 2019, and the forecast based on announced projects, which we know without a project out of China. There's a forecast again of doubling the capacity from more than 650 megawatts up to 1,260 megawatts till 2026. So this graph shows you there's really huge potential, huge capacity, and also a lot of, as a near future, a lot of projects in the project line and will be realized in the next 2 to 3 years. Yeah, coming already to my last 2 slides, I just want to summarize shortly what are the advantages of solar process heat. On the one hand, of course, a long-term constant energy price for about 20 years. So you have to invest once, and then you really can calculate with a constant energy price. Very low OPEX costs, especially if you are operating with non-concentrating systems. You don't really have a lot of maintenance costs, and also the electricity demand for pumping, etc., is quite low. It's very easy to combine this technology with other renewable energy technologies, and it really makes also sense to do this. Proven technology for temperatures up to 150 degrees with the non-concentrating systems, and also higher with up to 250 degrees with the concentrating systems. It is a decentralized energy system, and this gives you also a high security and also the security that you can run your production line with this technology. And there's no dependency on the world energy market, as you really can calculate with constant energy price. Coming to my conclusions, summarizing, the decarbonization of the industry is going only through these hybrid energy systems in the future, and there's a high potential in different industry sectors based on this temperature level. So this is a crucial point to know about this temperature level. It's important to have a kind of a pre-feasibility study, also with economic check, to know where to integrate and which kind of technology makes sense. And of course, energy efficiency as a first fuel has to be fulfilled before to install renewable energy sources. And then, of course, it's always important that people on site really have this willingness, maybe also to change process technology in order to reduce the energy demand and be more efficient. Renewable energy depends on the specification of the location. Do you have biomass? Do you have biogas from waste, etc.? But especially also for solar installations, the solar irradiation is very important. Space availability is important. And of course, the production times and the load profile is important. If such a solar process makes sense in the for the production. And then check the subsidies, for example, possibility for subsidies. And if you do this, and if you go for green energy for solar processes, then you have really a technology with a constant energy price over the lifetime of your technology. Yeah, coming to my end, thank you very much. I hope I could give you a brief introduction to the technology itself. Unfortunately, I cannot stay till the end of the webinar because I have a meeting at 11. But if there are questions, Peter and Wolfgang, they will take over and will answer these questions on this relation from the technology point of view. Thank you.
Thank you, Christoph, for this very nice overview over the technology. For those who came later, you can ask questions on all the contributions at the end in the Q&A session. We will come to that later, but now we come to the second presentation in today's webinar given by Winfried Braumann of RENAG, Austria, on financing models for ship projects. So please, Winfried, the floor is yours.
Thank you very much, Peter. I'll try to share my screen. Is it visible?
Yes, perfect.
Okay, thank you. Yeah. May I start with a brief introduction on RENAG? RENAG Holding is a development and financing company in the renewable energy sector. We have developed and financed a lot of wind farm projects and PV projects in Europe. We have also developed and are operating small hydropower plant in Bolivia, in Peru. We are participating in European and national research projects in industry and buildings, also for energy efficiency and renewable energy topics. And we are also doing some work in the e-mobility sector. But let me start now briefly with an overview what I would like to present in my presentation. Well, as you have already seen, other than with photovoltaics, the replacement of fossil energy with renewable energy generated by solar thermal installations has not yet arrived in the decarbonization mainstream in industrial production. One reason for this is certainly that such projects are demanding in terms of planning and technology. However, planners and manufacturers of solar thermal systems are also complaining that the economic viability of solar thermal solutions is often not clear, and it is therefore difficult to finance such projects. In my presentation, I would like to show how the economic efficiency of such projects can be analyzed and presented, and how economically viable projects can be financed. Having said this, this of course is not what I will now show is not only applicable for solar thermal generation systems, but in principle for all decarbonization projects. So you may find little specific topics about solar thermal, but I hope it will helpful in any case also for what you are pursuing. So I would like to show right at the beginning of my presentation that it is actually very easy to distinguish between uneconomical and economic projects at a first glance. The economic viability of energy projects is, as for all other types of investment projects, a question of the positive present value of investments. This positive present value of investments is calculated by the present value formula, which are shown here. It seems complicated, but it opens a very simple way to estimate the economic viability of projects in which fossil energy is to be replaced by renewable energy, for which only the annual energy costs are needed. Projects are only economical compared to fossil energy source projects if the investment and operating costs accruing during the economic life of the new plant are not higher than the costs that would have accrued with the old plant during this period. So if the new plant has an economic lifespan of 20 years, then the savings on fossil energy within these 20 years must be higher than the investment costs of the plant. In the present value formula, also the interest rate has to be taken into account, which expresses the cost of raising capital. If we would assume an interest rate of 5% and an economic lifespan of 20 years, the investment costs should not be higher than 13 times the energy cost. So, as this chart shows, an investment of 1.3 million with an interest rate of 5% can be repaid over 20 years. So this is 13 times the amount of the annual energy bill, and therefore we have kind of a savings multiple, savings of fossil energy of 13 if we do not calculate with other costs like OPEX. If we include OPEX, we include OPEX, it doesn't look very different. OPEX of the renewable energy plant, of course, is reducing the savings of fossil energy, and therefore we need only a lower OPEX and CAPEX amount can be covered with those savings. So in this case, we would have a savings multiple of 10. I have assumed here that the OPEX for the new plant are around 15% of the savings on fossil energy. So if you only have at hand the annual energy cost, you can use them as a first rough indication of how much can be invested in a decarbonization measure. 10 times up to 13 times the annual energy bill might be viable. Multiples above this, 15 times, 20 times, can only be justified or might be justified by the assumption of rising fossil energy costs and rising CO taxes. But if we assume stable fossil energy prices, this multiple range of 10 to 13 indicates some limit for investments which are viable. Of course, the profitability calculation of a project must be carried out in a much more elaborated way and should be based on certain principles, which I would like to talk about now. As we have already said, a decarbonization investment project is always about saving fossil energy consumption and using the saved cost for fossil energy to cover the investments to be made on the renewable energy plant, including financing costs and the running costs for renewable energy generation. In this regard, capital expenditure on investment, financial costs replace energy costs. They are constituting in a cash flow calculation the negative cash flow. The fossil energy costs, which are saved, in our calculation are constituting the positive cash flow. In reality, of course, this positive cash flow does not consist of an inflow of cash to the company or to the project, but of the saving of cash that would otherwise have flown out of the company to pay for fossil energy. The cash flow here in our calculations is therefore based on saved cash and not on actually collected cash. For preparation, we need a stepwise analysis and an optimization approach, which is based on treating energy production or energy consumption as energy cells. An energy cell is a definable technical system that either consumes or generates a measurable quantity of energy and that needs to balance its energy requirements or its energy surplus. A power plant, therefore, is an energy cell with energy surplus, and a production plant is an energy cell with energy deficit. The energy demand or the energy surplus of an energy cell is determined by the infrastructure and the environment of the energy cell, and this is independent of other energy cells. As an example, the energy production of a solar thermal system is defined by its technical design and, of course, the climatic temperature and solar radiation conditions at its location. Because of the independence of energy cell, the calculation of the present value of an investment in an energy cell has to be calculated separately for each cell. In our case, it has to be calculated separately for the production unit, where we will talk about energy saving measures, and the energy generation unit, which will be a solar thermal installation or a storage system. By changing the infrastructure, namely by investing, the energy production can be increased or the energy demand can be reduced, and this investment has to be calculated whether it's economically viable or not. It's also important to say that the energy, that the production system will have a changed load profile with lower consumption. And this also has to be included in our calculations. We need such detailed load profiles, at least on an hourly or maybe quarterly of an hour consumption or production basis. And we will, the calculations derived from such load profiles then present as monthly or annual cash flows, but the basis should always be detailed load profiles. Well, let's come to the first step, which might be the even most important step because it sets the framework for the calculations. We have to define the fossil baselines. For this, we have to estimate for this baseline the fictitious, of course, future energy consumption in kilowatt hours and represented in the load profile for the fossil energy supply system. We have to make up our minds about the future price development for the fossil fuel used in this system, including CO2 taxes, etc. And we have to calculate the future OPEX, like maintenance, repair, electricity costs, consumable, etc., of the fossil heat supply system. So baseline always for the heat, for the fossil heat supply system in the first step. The load profile of the consumption of fossil energy in kilowatt hours is known from the past, and therefore we can use it also for the future. For the operating and maintenance costs of the existing plants, we can also use our experience in the past. The cost of fossil energy is, of course, much more complicated. We must estimate on the basis of assumption about future development of energy costs, a development in our case for 20 years, also taking into account future CO2 taxes or future costs of CO2 certificates. This may seem, and in fact it is, somehow speculative. And unfortunately, this estimation has also the greatest impact on the profitability calculation because the energy price, as you have seen, is reflected in the profitability calculation with the multiple of the savings, which I have already described. So it has an impact of 10 to 13 or even more times of the estimated annual value. This, of course, might seem very problematic, but maybe it would be better to focus in this regard on the baseline, not primarily as an estimate for future profitability, but laying the ground for an investment which is representing a hedge for the company's future energy costs. If you estimate the future cost of gas in this baseline with, let's say, 6 cents, and you are implementing the investment in renewable energy then based on this planning and on this calculation, then you can be sure that the actual future renewable energy costs will not rise above those 6 cents per kilowatt hours. Of course, investment cost and OPEX are in line with the projected investment as it has been planned. Well, until now, the approach to assess the profitability of a renewable energy project is based solely on comparing the costs of fossil energy supply with the costs of renewable energy. However, the replacement of fossil fuels with renewable energy in production can, of course, bring further advantages, so-called additional benefits. CO2-free products can fetch a higher price on the market. A higher achievable sales margin of products produced with renewable energy is the same as a discount for products produced with fossil energy. This discount can be treated as being equivalent to a higher energy price of fossil fuels, and by adding this advantage as a markup to the fossil energy price in our baseline calculation, the energy savings will be higher and the profitability will improve accordingly. Another example may be that financing costs for investments in renewable energy are lower because they are in compliance with the EU taxonomy. This can and should be taken into account in the profitability calculation by using the corresponding lower interest rate, which can be lower than the interest rate which is normally used by the company or in the context of the company for discounting the energy savings, which also in turn improves the profitability of these investments. So to the extent that there are additional benefits of renewable energy, they should be included in the profitability calculation in a quantified manner, of course. So if we look briefly at breakdown of this baseline of the calculation, it's quite simple. The future fossil energy consumption times the future fossil energy price gives the future energy cost, and added with the OPEX on the fossil energy system, we arrive at the baseline energy savings, which is treated as a positive cash flow. In the next step, we are coming to possible energy savings in the production plant. As Christoph Brunner has already mentioned, this is a very important step according to the energy efficiency first principle. And therefore, it has to be determined which investments are economical and what are the necessary investment costs to reduce energy consumption in the production unit. Measures which can be implemented on this level are, for instance, the reduction of energy losses by insulation, the installation of heat exchangers, some mechanical measures or improvements, and of course, very importantly, the optimization of energy control and energy management systems. These mentions will result in investments, but they will result also in a changed energy load profile. And this also has to be regarded here. So again, looking at the calculation sheet. We are starting here with the CapEx. I have to mention here, CapEx have also to be inserted on a net base. So subsidy have to be deducted from the number which is used here. We are then looking at the energy efficiency load profile, at the energy savings against the baseline energy consumption, which is the load derived from the load profile of the fossil energy case, multiplied with the fossil energy price. Then we have the energy cost savings by energy efficiency. We have to add, if there are OpEx for the energy efficiency investments, we arrive then at the total cost savings by energy efficiency. This has to be discounted by the interest rate, and this then has to be compared with the present value of the CapEx spent on the production unit in order to find out whether we have a positive present value. And of course, or normally, we will only implement investments insofar as they are economically viable. We come to the third step. The third step is the selection of the solar thermal heat power plant and of the capacity sizing of this heat power plant. It is advisable for finding the right solution to compare the levelized cost of heat of different solar thermal options. The levelized cost of heat is the cost per kilowatt hour that characterizes a plant over its lifetime when using the entire generation capacity under local, environmental, climatic, etc. conditions. It is calculated by dividing the total of investment and financing cost plus OpEx by the kilowatt hours produced over the lifetime of the plant. So it's some similarity with calculating a present value of the investment, but this time we would like to find out the figure for the kilowatt produced over the lifetime. The power plant solution with the lowest levelized cost of heat should provide also the lowest cost solution if its energy generation capacity is fully used by the production unit. So if its production profile fully matches the load profile of the production plant, which very rarely, of course, will be the place, but just for starting the calculation. If these levelized energy cost of heat are below the baseline energy cost, there is some room for a higher capacity because the investment will have a positive present value, which might be even quite substantial. By adding additional capacity and, let's say, taking into account some underutilization of the capacity, the profitability is reduced, but is reduced only or should be reduced only until the capacity where the investment still has a positive present value. This then means, of course, that looking at maybe briefly again at our chart, we have then certain CapEx minus subsidies. We have from this kind of optimization process to select a solar thermal heat power energy production load profile. We will derive the energy delivered to production. again multiplied with the fossil energy price, and then we will have the fossil energy cost savings by renewable energy, plus the OPEX for the solar thermal power plant brings us to the total cost savings. They are, of course, lower than not accounting for the OPEX. This will be again discounted and compared to the present value of the solar thermal plant capex, and will show, if we follow those steps, still a positive or slightly positive present value of the investment in the solar thermal power plants. We have, of course, with this additional step covered, or in most cases, it will only be possible to cover a part of the demand of the production line. Again, because the production load profile will not be met by the generation load profile of the power plant. There is, of course, a trade-off between rentability and full decarbonization, but we can add here a fourth step. Sorry, this is yet the right one, which has been already mentioned by Christoph Brunner. We can add additional energy cells. Either we can add a storage solution, or we can look for additional energy consumers on site. Could be other parts of the plant which are not part of the production unit, or could be also third companies which are close and where the surplus energy could be used. I will deal here primarily with increasing capacity utilization through storage solutions, and show the calculation here. The use of heat storage systems that absorb excess thermal energy from the solar thermal system and then release it to the production plant with the energy generation of the solar system also means the increase of the replacement of fossil energy. In modeling, a heat accumulator is an energy cell that has both a load profile and an energy generation profile at different times. The coverage of the load profile of the storage has to be derived from the generation of energy surplus by the solar thermal power plant, and the heat release project has to be matched with the load profile of the production plant for the energy demand, which is not covered by the solar power plant. In the cash flow calculation for the solar power plant, the absorption of excess heat by the heat storage is not considered, because this does not directly result in energy savings from fossil energy. The fossil energy savings, which are produced by delivering energy from the storage to the production unit, are attributed to the energy storage to the extent to which has been calculated. These savings in fossil energy costs are then considered in the calculation of the present value of the investment and operating costs of the storage facility for its economic lifetime. So this is how an energy storage unit has to be added up to this stepwise preparation. We are only considering the energy delivery of the energy storage unit to the production and multiplying with the fossil energy, and then adding again the OPEX, and then we will arrive at the present value of the storage plant, and we will see whether this still is positive. Well, if we have gone through those steps, we will have sheets of present value calculations and, of course, therefore, of cash flow calculations for the separate energy cells we have looked at. In our case, it has been the production unit, it has been the solar thermal power plant, and it has been the storage unit. Those calculations and optimizations have been made separately, corresponding to the postulate of the energetic independence of each energy cells. This approach allows scenarios and sensitivity calculations per energy cells to be carried out. And of course, the effects on the economic efficiency of the overall system can be easily consolidated. They just have to be added up. And if each of the units and the investments in the units are viable, then of course also the total project should be viable and therefore can be implemented. Well, with the detailed presentation of the technical and economic optimization of the energy system through cash flow calculations, which are allowing for scenario and sensitivity analysis also by financial people, the basis for financing the overall project should be laid. Projects whose profitability and economical viability is well and comprehensively documented should be eligible also for financing, and experience shows that financial experts who are convinced of the profitability, who have been convinced of the profitability of a project, also will find ways to finance such projects. But nevertheless, I would like to outline now who can finance, such projects and how financing for such projects can be structured. Let's start with the case of investments by the asset owners, own investments in its own production plants. Well, generally speaking, investments in production facility, which are usually including process heat supplies or the gas boiler, whatever, have traditionally been carried out and financed by production company themselves. And an investment project where the profitability is well documented by cash flow calculations as presented above, should at the first step convince the financial manager or the owner of the company to provide the necessary funds, and should also enable the company to present such an investment case to banks to obtain debt financing, primarily by investment loans, but leasing financing is also possible. I think in this case, all proven investment financing instruments are available for companies' own investments in renewable energy. And I also think that most, corporate departments in banks should be able to follow the logic of such calculations and therefore provide the necessary financing. However, we have also the possibility of third-party financing. From an economic and financial point of view, the internal profitability of own investments, shown by the way as we have just discussed it with energy savings, can be transformed into an economic investment project of a third party, where the third party undertakes to make the investments and finance it also by itself, and receives the savings achieved in the company in return. This time, of course, not as an internal cash flow, but as an external payment of the company to the ESCO. The business model of the energy service company, which is built on this principle, of course, can be used for decarbonization projects in industry. With this business model, the company does not have to invest itself and only has to pay out the energy savings generated by the investments to the ESCO in return. It should be mentioned here that this business model of an ESCO investment can also be used if a solar thermal system delivers heat not only to one company, but to several companies. In this case, a joint venture of these companies, for instance, also within the framework of an energy community, can take all the role of the third-party investor. So companies can create their own ESCO in this way and therefore avoid own investments and own financing. The good thing is that a business plan for such a company, for an ESCO or a special purpose company, can be directly derived from the calculations we have made for the investment project. Because what we have already is the cash flow, the revenues from fossil energy cost savings, which turns into a cash flow. This can be derived from the added up sheets we have seen before, and we know already the total capex. What we would to have here in order to arrive at a business model would be the financial structure. So we would have to think about the necessary debt equity ratio. We would have to find out for the debt part what the repayment and the interest conditions are. And we would have to add also some administration cost because there will be some additional cost if the project is operated by a third company and not by the company itself. But we then will arrive at the usual structure of such cash flow calculations needed for project financing, which is that we will see the cash flow available for debt service. We will see the debt service, what has to be paid to the bank or to the provider of debt. We will see that the cash flow which then the remaining cash flow, which still is available for distribution to equity, we can calculate the very important debt service coverage ratio, at which always banks or debt providers look when they want to decide on the size and the conditions of that. And we can also calculate the internal rate of return for this special project company. So in the case of large project, a separate project company can be founded on this basis, which then can implement the project with equity, debt, and project financing structures. An SPV can do this, but also, of course, the ESCO can do this as a third company. Because for smaller projects, which can be implemented as ESCO projects, it would be necessary to have the same calculation even without setting up a separate project company, which could be too expensive or too complicated. In this case, the ESCO can use the instrument of forfeiting the long-term sales of receivables to refinance the debt capital it has raised. And this is something, I think, which will now be presented by the next speaker by Sławomir Hus. Thank you very much.
Thank you, Winfried, for your contribution. Very detailed layout of project financing. The questions, please note down your questions. You can ask questions after we finished with all the presentations. So as third and final presentation, I want to give the word to Sławomir Hus, partner of Solus Capital, presenting on experiences on financing small-scale decarbonization projects on a cash flow basis. So please, Sławomir.
Good morning, everyone, and thank you, Peter, for having me. I hope you hear me well. Let me know if there is any issue, but I assume everything is fine. Yes. Well, thank you for this previous presentation. Especially, I'm grateful to Winfried for such a smooth transition from his presentation to the way how we operate in Solus Capital. Indeed, we are focused on a dispersed small-scale energy efficiency investments. I'm a partner in this company. We're based in Zurich. We started in 2017, and last year, 2022, we launched our first investment fund. But before I jump into the presentation, which I have ready, I wanted to start with a little introduction of myself. And my personal story, how I ended up in Solus and what I do. So I've been dealing with energy efficiency investment for the past 9 years plus, nearly 10 years soon. Somewhere in 2014, I joined a large technology company focused on energy efficiency, mainly lighting, but also healthcare. At the time, this was it's obviously a company that has a lot of values, so I really valued joining this company. I was appointed to scale up efficiency business, and a bit later, 2016, I was moved to head of Europe, solely dedicated to scale up efficiency business, meaning light as a service. So I had a large company behind me, fantastic technology, but obviously the lighting projects small, dispersed, and if you add the multi-country colorful picture in Europe, you can imagine how complex it was. And it was a time when I learned two very strong lessons about efficiency, especially about the small-scale efficiency projects. One is, even though people like to talk about technology, they would like to talk about sustainability. I mean, obviously 2023 versus 2014-16 there's quite a difference. Still, the topic of sustainability was present there, but no one really focuses on efficiency as long as it's pushed by some regulation or it's extremely easy. Otherwise, everyone has always something else to do every day. You will, if you're a CFO, CEO, CTO, technology manager, site manager, there's always something more important to do than focus on a nice to have efficiency project, unless it's pushed by the regulation, but then it's a different story, obviously. So if you want to scale up efficiency small projects, you have to make them extremely easy. So these people do not actually burn their limited time. That's the first lesson I learned very quickly. The second one is also that these technologies, and that's also was nicely mentioned by Winfred in his slides. Well, these technologies typically mean that they are more expensive than regular ones, and moreover, even if they are not by essence more expensive, there is an investment needed. So in essence, there is a cash outflow needed to do this. And if again you make it easy, but not connected to the funding that is embedded in the value proposition, you immediately get again diluted, because if someone needs to go to a bank or needs to start talking with the finance department, quite often what we see now, you have to go to the headquarters when someone in one country can't decide for someone in another country, and you end up with a long discussion, 6 months, 12 months, and the project is not done. So first lesson was it has to be easy. The second lesson, the easy solution has to come with a financial solution. So these were the two lessons I learned when I was responsible for scaling up efficiency business in Europe. I had very good sales team across the whole Europe. I had very good technology. Still, without these two things, I was not able to scale up. Ultimately, successfully, we made it. Of course, myself and my team. But also by that time, I met fantastic people, and with these people, I'm forming now Solus Capital. When we actually scaled up from something that was much smaller at the time, now we're actually promoting efficiency investments across Europe, and that is how everything started. Now let me present my slide share. I also would strongly insist on making this as interactive as possible. So I will keep the Q&A window open. Make it open. I will try to watch the Q&A, and if anyone has a question, please ask. I will try to address it during my presentation. So again, Solus Capital, we're a team of 12 people based mainly in Zurich, but also in Dublin. A small comment: recently we opened a third office in Germany, in Munich. In essence, what we do, I could talk about we're the investment advisor whatsoever, but in essence, what we do, we connect institutional investors on one hand with portfolios of dispersed small-scale energy efficiency projects across Europe. We team up on one hand with technology companies, mainly the ESCOs that were also mentioned in Winfred's presentation, but also with the technology providers like big companies selling their own technology. We team up also with project developers, so companies having the forces in the countries to develop the projects. This is especially valid when you look at what's happening currently with the PV in Europe. And on the other side, we are working with the funding providers. So not a very usual funding providers like I mentioned before, like banks or leasing providers, but more institutional money, like European Investment Bank, which strongly supports our initiative. And the biggest investor to Solas being the MIAG. It's a Munich Re, the large German insurance group. We have also some smaller investors, equally important, obviously. We're fully aligned. I could be talking about Paris Agreement and all sustainability goals. Obviously, I'm proud to say, as very few financial institutions, we qualify as so-called Article 9 SFDR. It's a relatively recent SFDR regulation introduced by the EU. Article 9 is the most, it's called so-called dark green, so the most green investment strategy as you can imagine in the current environment. Not many funds qualify. We do, because we only do investments that are fully sustainable, and we look holistically at this topic. Slowly jumping to the next slide. Listen, the key message, how we actually make the difference versus the standard funding is, we looked from the perspective of people who understood how a small dispersed projects could be and must be financed in order to scale up. So what we did, we started with a large financial institutions, and obviously banks are important element in financing of the efficiency. However, banks, they do have their own regulations, and they have certain minimum thresholds. So when you're setting up a large PV farm or a large wind farm or a large investment in heating, as presented by Christoph at the beginning, obviously bank may be an interesting option. However, when you are talking about several small scale projects, or a project that is something not immediately connected to a large project, but something that's a spin-off, for example, on an upgrade of something, then the banks typically will not be interested because it's too small and too cumbersome to do the due diligence analysis whatsoever. So on the other side, we also used to look at the other type of funders, which were the leasing providers, so very much asset-driven, right? But again, the asset-driven, even though with the efficiency projects and heating could be a nice example, you have the asset. But on the other side, the asset funders, they look from the perspective of how can I secure myself on the asset itself, right? So what is the residual value of the asset? How do I know the technology? How do I know what happens with a given boiler or a given heating facility after a year, after 5 years? I mean, the example I heard many times talking to the leasing providers was, well, but the good example are the cars, yeah. And I heard this example of cars several times, and I can mention it again. When the asset providers, they think about funding, they think about a little bit like a car-like funding. So you have a car that is a second-hand in the market. You know more or less if a car is driven normally, what is the value after a year, after 2 years? You know what is the product warranty? You know the producers. You know the technology. I mean, there is almost no risk if you structure the deal properly. And on the other side, I had once a discussion with a very senior banker, was talking at the time about LEDs, and he listened to me, and he wasn't very polite. So he, at some point of time, he literally started laughing and said, there is no, LED is not an asset. Even though you think it's an asset, it's not an asset, because there is no second-hand market, because no one will buy a used bulb. And this is how they looked, how the leasing providers looked at the time at funding assets like LEDs, for example. There's no second-hand market for a bulb, so the moment you install the asset, its collateral value becomes zero. If then it's uncollateralized, then it's obviously not interesting for them. So understanding the shortages of the two types of funders, we started looking from a completely different perspective, because if you look at the efficiency investments, especially investments connected to the core business. I very much like the Christoph presentation about the heating systems. Yes, the asset that will be installed will be somewhat specialized. So the residual value and the concept that you could take the asset and just sell it somewhere else is quite remote. But on the other side, the client who enjoys the investment, you're somewhat not becoming on their cash flow list. You're not becoming someone who has to be paid somewhere down once everything else is paid, but you're becoming one of the crucial elements that has to be paid, because the production processes or whatever the processes they run need this. For example, keeping the heating example, they need the heat for the production, right? So suddenly you become one of the crucial elements of the payment logic. So in other words, if there is an efficiency project that generates certain cash flow, we actually in Solas we look at the cash flow itself, not at the asset. And obviously, from the security perspective, we still structure it that the asset is a collateral, but it's a secondary element. Mainly, probably I would say just to avoid situation that this asset somewhat gets taken by someone else. But the key element in the efficiency investment, which is the basis for our investment, is the cash flow. So actually, what is the positive cash flow that is generated by this investment? And what is the need of the client to pay it over time, right? And that's how we ended up with the model that I'm sharing on the screen. I try to, yes. So what we do is we, as I mentioned before, in Solas Sustainable Energy Fund, we team up with service companies. So the service companies that generate these efficiency projects, and we purchase the receivables. That's a legal status, but in practice we purchase the receivables. In practice we purchase the cash flow arising from this investment, from this efficiency investments. So in the long term we stay with the cash flows that the customers have to pay, with certain agreements with energy companies that they are responsible for any performance elements. If there are any guarantees whatsoever, then the service companies that we team up with remain responsible for their responsibilities. On the other side, as a financial institution, we do the job of the typical banks and leasing providers, as I mentioned before. So we take the credit risk, we provide funding. So somewhat we fulfill this role of a bank. I think important to mention is we are flexible. So also instead of somewhat trying to stick to a banker's type of logic where you have certain silos in the banks and certain products and the investment has to meet certain banks standards to fall under fall into a certain bucket. On our side, we have the capacity to work with the partner also to structure the product that is flexible enough. On one hand, that is flexible for the service partner, so for the ESCO or for the technology provider. For example, giving them a true sale, so off balance sheet for them. But on the other side, equally important is the lessons I mentioned at the very beginning is to truly scale up. You have to make it easy for the end client. So it also can't be that we impose certain conditions that are make the product then much more cumbersome and difficult for the client. So we structure it in a way it should be fairly easy to implement also for the ESCO, and we give them actually the salespeople of the energy companies. We give them the power to convince the clients and have financial solutions somewhere embedded. I will discuss this model in more details in the next slide. Important to say, as you see this small arrows on the bottom, we always stand behind the service companies also. So we're not the front runners. We're not trying to get to know the client unless there is such a need. In on other situations, the service company is holding the relations with the client. Yes, shortly going back to an intro. So bearing in mind the logic how we operate, let me just briefly mention it again. We've funded based on this investment logic. We funded an investment fund that was launched last year, 220 million euro, solely dedicated to small scale energy efficiency projects. We manage as Solas, we manage this fund. What you could say, investment manager, it's quite a financial job. I would say not really, because obviously on one hand we are the finance people, but on the other side, very importantly, is we also spend a lot of time with the energy and technology companies. So we spend time, one thing on structuring the products with them, but equally important, I must say, it's also time we spend on selecting the partners. I mean, if you start talking to technological companies in Europe, I mean, there are several, a lot of them at different development stage, a lot of them at different technology segments, a lot of them different sales approach, for example. Meaning that some of them are very much sales orientated, not long-term relation orientated. Well, when you think about long-term funding, I mean, it's quite important. On the other side, as I mentioned, we're connecting the financial institutions. That's less interesting for this presentation, so I will not be going down in the key messages. What was agreed with the investors? This is a fixed income, so it's a debt fund. So cost-wise, we're comparable to the banks. Obviously, there is a certain premium because we're more flexible, but in essence, this is a very reasonable product. And in terms of the EU support, also we not only have certain funding from the EU, but also we enjoy a credit guarantee, which enables us to accept certain credit of the off-takers that in other ways would not be eligible for funding. It's obviously not a last resort funding mechanism, but it broadens the scope of acceptance of off-takers and clients, especially when you look at SMEs across Europe. I mean, there's a handful of clients on the edge of being eligible for funding, and with the EU guarantee, that is obviously very, very helpful. Now, looking at our experiences, we've developed a product that allows for scaling up the small-scale efficiency investments, and there are few assumptions. I will go through some of them. The key one is we look at the capex cost as being the significant cash outflow for both the end client and for the ESCO. So we've developed a structure where we finance nearly 100% or up to 100% of the investment. If you remember what I said at the beginning about the ease of investment, that is also one of the criteria. I mean, if the customer has to put 30% equity or down payment, that is obviously a different story versus what we do, is we finance generally up to 100% of the investment. We provide a non-recourse, so we allow all the parties to stay somewhat in their comfort zones. So we understand technological partners, they do not want to have a long-term credit risk of the off-takers. That's not what they were developed for. That's not where their shareholders put their money. We understand this. We are acting as a financial institution, so we take 100% of the credit risk. We work across the entire European Union, so we're not focused on certain countries, even though for some private reasons we're sitting in Zurich, but this is probably geographically one of the most central parts of Europe, even though not entirely European Union. Very important one is when you talk about small scale projects, you have to understand that you're also taking the pipeline risk, because small scale projects, they come at certain pace depending on obviously the scale of the partner. So what we do as part of the preparation process, which I mentioned on the previous slide, we also assess the potential for the pipeline, and we take this risk. All right, so we hope that the partner will be able to deliver certain volume of projects, but that is something that comes over time. And with the funding structure that I presented two slides back, we sign a framework agreement with a partner, so we define the parameters of how the funding will work for each particular small project, but we finance them once they come. One hand, it gives ESCO or any technological partner comfort of the funding. That's one thing. But very importantly, also we give very clear conditions also in terms of the credit acceptance, which allows to scale up and allows to sales force of this partner to be more confident when they speak and they select the end customers. Again, based on my experience when I was responsible for scaling up efficiency business in Europe, that's extremely important that you have a straightforward message to salespeople what they can do, which clients they can speak to, not on a case-by-case basis, which is very annoying and taking obviously a lot of time. We finance long-term. Long-term means we go visibly beyond what bankings can do. We're not afraid of double-digit funding. We can go even up to 15 years, 15, which again, going back to the ease of implementation is very important, because for some technologies, the payback is fairly long. I mean, obviously, there are certain factors Winfried was mentioning that could increase or speed up the payback with all the carbon taxes and the positive look of the off-takers, of the customers. But still, the paybacks are relatively long. So the tenor that we offer is in line with the payback, so that the end client do not have to pay, and the whole product can be structured actually that the funding is the repayment is in line with the savings. It's what we do as a true service offering. It's a bit more of a financial aspect, but for the ESCO, we take contractually all the risks that are not associated to their performance, which is very important because it also allows them to keep a clear and clean balance sheet, and that obviously allows them to be more credible towards potential equity investors or potential banks. We can also structure the solution that is IFRS off balance sheet. Obviously, devil in the details. I mean, I spent all of the listeners that have certain experience with IFRS, you know very well how difficult it is and how judgmental IFRS is. I can only say we spent some time, and we have some clients that were able to structure a solution that both ESCO and the off-takers, they qualify this investments off balance sheet, and we're still as a funder happy, and we're happy also with the risks that we're taking. So there's not one party that's overly taking the risk. So we do it in a very healthy way. Last but not least, I generally already mentioned this. I mean, we work on a portfolio basis. This is very important for the dispersed small-scale efficiency projects. I mean, no option. I mean, it's self-explanatory. No option to work scalable if every project has to be analyzed with the same scale and legal due diligence, technical due diligence has to be performed. It has to be done on a portfolio approach. Obviously, it would be easy to lose completely the conditions, but from the investor perspective, we obviously cannot. So we've developed certain approach in Solas that we are very confident, and we know how to assess the portfolio. We know how to set the conditions for the future portfolio, which is equally important for ESCOs, and we actually, with every technological partner, we develop the way of working so that we're also confident that the quality of the portfolio that will be generated over time meets our investment criteria, meets the technological criteria, and we have also the mechanisms that we can perform certain checks without making it overly cumbersome or costly to partner or costly to off-takers. We like to say we're doing things a bit better than the financial institutions. So maybe finishing our lessons learned and the approach to small scale funding. I wanted to show 5 differences between us and the financial institution. That also boils down to how differently you have to approach a small scale project. One is, because we're not a bank, we do not have to do a thorough KYC or any other analysis customer by customer. We can do it on a portfolio basis. Our experience working with large financial institutions was always that they always analyze every deal separately. What was I remember from the time, again, when I was responsible for scaling up efficiency business, one of the first questions I got when I was introducing a deal to a bank or leasing company, let's say this old legacy funders, one of the first questions was always like, who is the contact on the customer side? Because we need to call them, we need to send them all the KYCs, forms, etc. So, and obviously, as you can say, going back to the lessons which I mentioned at the beginning, that everything has to be easy. That is an opposite of easy, right? So if a customer has to deploy people, as a discussion with banks, there's always hesitation. Why do we do it? Maybe we should speak to other banks. Maybe we should call our own bank. Maybe we should call our headquarter, and the whole process gets diluted, and then you can only multiply your efforts by 10 or 20, and then still don't close any deal because everyone is somewhere in the talking instead of moving forward. What we do is we solely rely on the process that ESCO does. So they are in the front line. They speak to the clients. We make sure that they ask proper questions, to make sure that they deliver proper documents. But we do not step into the front line. We know small projects, they require certain efforts to close them. If we make the closure process too cumbersome, we will lose certain part of the deals. We can also predefine very quickly the qualification process. Again, my experience working with large financial institutions, whenever we try to somewhat get quick and dirty, 80-20, you name it, procedure to pre-check the customers, not at all any binding, but just a pre-check so that I could send salespeople certain conditions. It always boiled down. It depends. We don't know. There is different sentiment, different segments. We cannot give you anything. You have to come with every client separately, and our risk team actually will perform the standard analysis. While we learned, again, this is something that becomes problematic, cumbersome, and not helping to scale up. So we've developed a quick procedure based on external credit sources that we can support, but salespeople actually can provide can do. the analysis by themselves. Third one is actually my favorite, and it's very simple. So we're working across the EU, so we can offer solutions identical in every country, as long as there's no legal requirement in a given country to do something extra. While with the banks, if you move to sometimes even different region in one country, but but especially when you move to different country, even with the same bank, same logo, you always start from scratch. It's different team, different procedures, everything is different, and so the scalability of ESCO across geographies is heavily limited. Working with these institutions. On the other side, we allow ESCOs also to grow, to think big, and we somewhat support them in making some investments also outside the country. And I can say proudly, a lot of partners I work with, if actually they do it. I mean, obviously we're just a small puzzle in it, but they also see, after conquering certain market in home country, they start looking at bigger countries, and they look where else the business could be done. So it's actually very positive to see that these things happening. Number 4, I think I already mentioned this. We understand that scaling up small projects requires knowledge and bit of focus on what exactly is needed. How can we do it? I mean, it's easy to say, again, as it was mentioned on Winfried's one of the last slides, forward-fighting, receivables financing. I mean, it sounds fairly easy. In practice, I can say this is by far one of the most complex financing options, and you need to spend time on structuring this properly. Also advising technological partner to do it properly. You rely somewhat as a funder on the quality of the contract that has been delivered by the partner. So it's also important that you educate the other party. We understand, again, the specifics of the small scale deals, so we do it. Last but not least, again, very short difference. I mean, we understand, to make it easy, you have to make it for the client cash positive or cash neutral, meaning that the savings compensate the payments for the solution, for the investments over time. So we match the project lifetime with long tenors versus the financial institutions that they have their own tenors, and they obviously impose the tenor based on the credit analysis, not based on the project duration. Roughly, this is it from my side. I mean, I have one case study, but it's just one example. We work with several technology companies. We've already deployed some part of the funds. I'm sharing just one case study with a German energy service company focused on technological efficiency, among others. They work a lot around heating technologies, mainly heat pumps, but also heat traps, steam traps, steam generation. So all vital technologies saving CO2s. We've provided them a commitment of 33 million. We've signed agreement somewhere last year, and I can say we're almost at the ceiling of what we committed. So the cooperation works well, and it's really positive to see that the ESCO model works well for them. The good thing is they were already involved with the partners, so they had a very strong relation with large off-takers. So their clients are big companies, big logos. I mean, I'm sure if I gave the logos, you would recognize them. Still the very positive thing is, still the funding is needed, and it's not because their clients, they don't have money. They do. They are cash rich companies. The thing is, they like the ESCO model because it ticks a lot of boxes. I mean, they can scale up faster without deploying their technical people because they trust the ESCO that we're working with. So this ESCO actually performs. They are almost like the second technical team that works in-house and develops the efficiency projects. On the other side, with the funding provided from our side, they do not have to wait for the financial budget, have any in-house discussions for the next year. Can we do it? Can we not? It's more a straightforward payback period decision, and decision is taken, and the project can be implemented with the funding. And from our side, we're talking about from a bit larger projects, few million euro, to very small ones, and by small ones I really mean small. I think the smallest one was like 10,000 euro, just to give you the feeling how low this can be. Still having a standard approach, framework agreement conditions decided. You don't have to, that the marginal transactional costs are marginal. So you can provide a 10,000 financing, and it still makes sense. While with the traditional approach, you would need to deploy lawyers, etc. And I promise you, the invoice would be much higher than the project value. Lastly, interestingly, that's also one of the cases where ESCO developed a project contract where the end customers they qualify this IFRS off balance sheet, and with this, they also like it because from the balance sheet perspective, they don't have to show the investments, so it's purely on the P&L as monthly invoice for services. I will stop now. Let me finish presenting. Yes, thank you very much. If there are any questions, please go on. Otherwise, yes, Peter, I'm going back to you.
Yes, thank you, Sławomir. So we come soon to the Q&A session, but actually before doing so, we have prepared for a poll asking also something from our audience. So maybe, Wolfgang, you want to briefly explain this poll?
Yeah, we also want your input on these topics after the presentations you've received. We created 2 word clouds in the Teams link here. You see the screenshot now. You should have a similar screen in your Teams application, and there should be this poll icon called Financing Ship Word Cloud. So if you click on it, on the right side, you should see 2 word cloud or 2 polls. You need to scroll down for this. It's on the right side. You can scroll down, and then you can enter 2 different questions. So on the one hand, one question is, what do you as a financial sector need from the ship community? So more from the technical side. And on the other hand, the second question is, what do you, ship community, need from the financial sector? So it's about bringing those 2 worlds together. So we would like to create a word cloud here. So once you see that, you can enter words for this. So I'm giving an example so you can see it. You can do that now, and then you also can vote on those words that are added by others. So you can put a thumbs up on it. Yeah. So you can do this while we also open the Q&A session that is now organized by Peter.
Okay. So we come to the Q&A session. So you can ask questions concerning all three presentations by either raising your hand in Teams or write your question in the chat or Q&A section. And with your question, please state your name and affiliation. So let me check. Do we have any questions yet? Not yet. So please come up. Maybe while we wait for responses, one question to Slavomir. What is your medium to long-term forecast regarding the market development of the financing solutions and projects that you presented?
Yes, thank you, Peter. Listen, we see a growing need for small efficiency projects. So we see more and more technological partners. They see the growing demand, and they need this. They need to scale up. So I can say sometimes we're somewhat compared to other financial institutions, but it makes sense when you have one or two larger projects. Then you start analyzing once you see that actually the demand is coming. So the interest of the clients is increasing. There's more and more need for a simple standardized product, and then we see them actually coming back to us with the message, okay, the demand is stronger than we thought, so we need to structure something that allows us for the flow cooperation, because I mean no one will be successful if we start talking deal by deal. So based on this, we see a growing need, and obviously when you look at the macro situation and the EU decisions, I mean this is obviously fully justified. I mean if you look at the super short term, I mean indeed, yeah, over the summer some utility prices went a little bit down, so there was certain worry that maybe with the utilities going down, people will stop feeling the pressure to move towards the efficiency solutions. But honestly, except for 2-3 situations where I got in some regions that indeed people a little bit cooled down in terms of the investments, in all the others we see what I said at the beginning. So a strong growth and a lot of demand for this type of solution. So long story short, the forecast is positive.
Thank you, Slavomir. We have one raised hand. Wolfgang, can you open the mic?
I did already, so Pedro, you can now speak.
Okay, thank you very much. I'm sorry that I couldn't attend the full webinar. I joined later, but I have a question, which, if I may, is almost adding a question to the survey. So my name is Pedro Diaz. I work for Solar Heat Europe. So we represent the solid heating and cooling sector at European level, and a lot of our work is with policymakers, so European national level. So if my question to the speakers is, what will be needed from the policymaker side, adding these also the European Investment Bank. So what will be needed in particular from the European sides to facilitate the financing for ship projects? Thank you.
Thank you, Pedro. Slavomir, do you want to answer, because you mentioned already some direct link to EU organizations?
Yes, so thank you, Pedro, for this question. I mean, it's a very broad question. I mean, I'm speaking from the finance perspective. So we already see certain support from the EU. As I mentioned, we already enjoy a having EIB as investor, and also we have the guarantee. So my view from the funding perspective would be that these products, which we utilize nicely, I mean, they obviously have certain capacities, right? So we're utilizing these products nicely. So my first and immediate request would be, let's make sure the good products that we use and maybe some other institutions use, that they do not expire, right? Because that's always the budget, and we need to make sure that the Commission and the EIB make sure that the budget is there for the next years, right? We have certain bucket now, but if the product works, that it stays, and we're not trying to figure out what could be even better than this, because if it works, then it works. Let's make sure the budget is there. When it comes to the stimulation of the investment itself, I mean, it's I don't feel like an expert, so I don't feel like I could say something meaningful here. So maybe I would allow someone else to step in.
Maybe I can add some aspects from the SHIP community, maybe. So I think what we really need from EU policies is that we try to keep the pressure, or to put it more positively, the momentum in the end user sectors to really look for renewable solutions. And that is reflected in many ways by EU policies and regulations whatsoever. So, of course, we would like to see that heating in industry is much more directly addressed, and solar thermal is also becoming more visible as a potential solution. Are there more questions? Or Wolfgang, do you want to add something related to the EU policies?
No, we are already ahead of time. Maybe, yeah. Please go ahead.
Yeah. Then maybe one question to Winfried from my side. You discussed the different energy cells in your presentation, and these energy cells can be defined on a small or on a bigger scale. So what would be the appropriate scale for developing decarbonization projects?
Yeah, well, it depends, of course. But the cell should be defined in a way that it should really be the size. Well, I start otherwise. Obviously, the energy producing cell for generating energy would be defined as the solar thermal plant. This is easy. On the other hand, for the production unit, I have proposed to define the cell as the production unit as such. If the production unit is also consisting, and it always consists also of other cells, single points where also energy is metered and used, you could go even below this level. You should do this only if this brings additional additional calculation possibilities of the parts of the measures which you would like to invest. So normally it encompasses the full unit which should be looked at in order to save energy, and only in special cases you would go lower down. You could, for instance, also define an heat exchanger as an energy cell, but normally you will not do it only as far as it is appropriate.
Okay, thank you, Wolfgang. Winfried. As far as I can see, we don't have more questions. So maybe we go back to Wolfgang. Would you want to show the results of the word cloud?
Yes, I can show that. So you should see it now in the Teams folder. So this is use the words that have been submitted for the 2 questions in the Teams. We can use this now. Also, we will further process it. If you still want to raise your thumbs for one word or the other, you still have the chance before you leave the meeting where you think, yeah, that's a good answer. You can upvote it by clicking on the thumbs up, either here in the Teams folder or in the Teams sharing app. So I think the need for turnkey solutions or uniformity in the project, structured projects is important for the financing sector to have a better understanding of the projects. And I think the SHIP community to have streamlined procedures that it's clear for them how to come to those financing options that also Slavomir presented. That there is also trust in the technology. I think that means trust in the new technologies, renewable technologies. So meaning that these are also likely to be financed. Yeah. So please, if you ask your last votes or your last words, and then we can summarize this. Thank you for your participation.
Okay, thank you, Wolfgang, and thanks to the presenters again. Thank you to all in the audience for your interest and for participating. And with that, I'd like to close this webinar, and we hope to see many SHIP projects financed and built in the near future. On the bottom right, you see one project in Belgium with a large parabolic trough solar field, which has recently been inaugurated. So we'd love to see more projects like that in the near future. Thank you. And with that, we close the webinar. Bye-bye.
Thank you.